Professor is very helpful. So just making sure that it's
I'm not as probabilities are like it took 50,000. I'm thinking more, so if you want to accomplish it, so yeah. Style transfer from class to
yeah, this is just like you do a grade, you don't know.
yeah, exactly. You know, like I was answering questions.
The solutions are all there too, right?
Yeah.
Yeah, I mean, there's stuff to apply to right now. On our side. We can talk about it. I just realized I didn't upload the slides for today, so I'll do that right now.
What format is
It's Apple Keynote.
Okay.
It's probably the best format.
I can believe that. I can.
Internet connection. Is the Wi-Fi working?
Yeah.
On the Uconnect?
Yeah.
Also my
It's hard enough to do one.
it's make it hard to
Do what?
It might take a while.
connect.
And the uploading it takes a
Oh,
while.
that uploading will be fast, but it will be very slow if I can't connect to it.
Whenever I upload my assignment, it's always
That's that.
Like the timing break. This is
Okay, sorry, I don't know, I can't connect. laptop denied, Wi-Fi.
You can try this.
What's that?
Try this.
I guess network is. That's right, I can just post it afterwards. It's like my Wi-Fi's laptop is. That's actually bad because I want to show some things. I was seeing the other. Hey, connected. Oh, you cast this. That'll work.
Or make sure that we fill in blanks, you know, it's like all sorts of things, it's a role blank, it's a role blank. So it says like a certain percentage of things on the job.
Okay.
It's really
Working. Sort of.
I'm not exactly people be on the things that they, you know, 4 to 5 and give them there. Anything else?
Okay, that's not for All right, let's get started.
It's 8 hours.
Okay. Everybody have a good break? Yeah? Everybody start on the latest homework over the break?
That's always good.
Oh, that's right. Good. Yeah. That makes sense. Let's see.
I have a question on like the next homework.
Yeah.
So we're gonna have to do those like turn in those proposals, I guess, by I think like November 3rd or something like that.
Yeah.
Any idea when we have like, I mean, are there any guidelines we need to go off or anything like that?
I mean, this is really not meant to be super onerous. This is just like, you know, there's something interesting that you want to try out. Don't make it too crazy. I mean, like, there's some really difficult deep learning problems out there. Don't pick one of those. Pick some topic that you know something about and kind of explore it. You know, and you know, last year we had projects, everything from like, I mean, there were lots of different things. There was lots of like training models from scratch. You know, like detecting a gun, like is there a gun in this image or not? You know, for safety reasons. I don't know. There was like cryptography ones using GANs to do cryptography. I don't know. There's all kinds of projects. So this is not meant to be like a big, huge research project. This is like, hey, here's some interesting area that I can work on. Whether it's like a applied problem or it's something like there's been many things that throughout the semester we've talked about. It's like, oh, that would be an interesting project. Like, I don't know, how do these models depend on? I can't think of an example right now, but I know I said it like many times already. How do these models or how does this optimize or something that depend on these parameters and kind of go through and explore that. So you'll turn them in and I'll give some feedback about them. Usually they'll just be like approval or maybe just like, hey, this might be way too hard, pare it down, or this might be way too easy, try to do something a little harder than this. It'll just be like that. And like the basic guidelines are just in the assignment, just like you just need to just do it exactly what it says, state who's in the group, what the project is, what data you're going to use, and most importantly on that is like they've done some research on this. Like there needs to be citations from 2 papers that you're going to read as part of this to help you kind of get up to speed on the ideas.
And last time you missed it, is there a policy on pre-grade requests?
Is there a policy?
Yeah, so like if we feel like there was a mistake in the grade we received from homework 1, can we have a TA relook at it? See whether it was a mistake or
sure.
maybe
No, that's I don't have a written policy, but I don't see why that that's a problem.
To send it through Canvas?
Sure, yeah, okay. That's already been done a couple times by a couple different people anyway, so.
Okay, cool.
Yeah. Everybody's visible here.
That's what I want to hear.
Yeah. Okay, other questions? Okay. All right, so let's get started. So we have a couple of weeks here of doing generative models, and we're going to talk a little bit about generative models today and show some kind of simple examples of generative models, and then the next 2 lectures after this, Alessandro is going to do a lecture on 2 different kinds of generative models, variational autoencoders and GANs, generative adversarial networks. So 2 full lectures on that. Alessandro is an expert in those things. So he says it himself. And I'm putting words in his mouth. And yeah, then there'll be, and then the following Thursday of next week, I'll do one more lecture on generative models and kind of tie a lot of the ideas together into more of like a theory of what's going on in generative models and the idea of variation and inference. All right, so what have we been doing so far? We have mostly been doing supervised learning in all the examples. It's mostly just I guess all has been classification. But supervised learning, lest you've forgotten, is the idea where all of your data for training there's both some data component and a label. And what you're trying to do is learn a function from the data, whether that's images, or that's text, or that's some row of numbers, or whatever else it is. You're trying to learn from that to the relationship from that input to an output. So we talk about it as prediction, but if you think about it, really what we're doing is function approximation. There's some function that generated this data, or that generated the data that's labels, and we're trying to learn that relationship between them. And so, like a lot of things that we've been doing fall into this category. So, this basic classification. Is there an object of a certain class in this image? So we've done this ImageNet type classification. We've talked about models for doing object detection, so not just noticing that there's a particular class in the image, but that there are multiple classes trying to do the localization of where they are in the image. These are all, all of these follow this example. There's our data, which you might think was the image, or if we're trying to predict these bounding boxes, the data is the image plus the coordinates of the bounding box, and also the class of the thing inside that bounding box. So, why it has different dimensions in all of these cases, but it's all been the same thing. Here, this kind of extreme example of semantic segmentation where we're labeling every single pixel. We're classifying it every single pixel. Yeah. Even image captioning, where we take an image, we want to write a caption, so that the label here, Y, is the caption. And we're trying to learn the relationship from image to caption. So this is supervised learning. So when we talk about generative models, we're often starting to think about the realm of unsupervised learning. So let's just remind ourselves what unsupervised learning looks like. So when we're doing unsupervised learning, we typically think of this as there's no label, there's no Y in this case. What we're given is just a whole bunch of data, X. And the goal here is not to learn this through this function approximation, not to learn this relationship between input and output, but it's to learn something about the structure of this data. So, if you've done any machine learning or kind of statistics courses or data science courses, you've probably seen a lot of these things already. So, clustering algorithms of all different kinds. So, clustering can be used for like a supervised kind of idea, but a lot of times what you're trying to do is you're trying to just notice that there's like a whole bunch of things that are kind of closer to each other than they are to other things. This is the same thing about the structure. Like, for some reason there's like a whole bunch of these things kind of like each other over here in our data space, and there's some over here, and so forth. Have you ever done any sort of PCA where you're learning your different directions of variation, and using that to do, you can use that for all kinds of things. Dimension reduction is a typical application for PCA, because you usually use PCA to, one, give yourself orthogonal coordinates for your space, your data space, but also to attribute the amount of variation to each of these coordinates, and then you make some decisions about, hey, I just want to keep this amount of variation of my data, so that corresponds to some number